Welcome to Neuroscience Update, presented by Naidi Bahradian. I'm an electrical engineer who has passion for neuroscience. Within this video, you are going to hear about the latest updates of neuroscience. Hi, today I'm going to talk about a paper of title A Multimodal View into Music's Effect on Human Neural, Physiological, and Emotional Experience. According to artificial intelligence, does music have any effect on our brain? In summary, artificial intelligence has shed light on how people's brains, bodies, and emotions react to listening to music. Music influences part of the auditory cortex, including the Heschel's gyrus and the superior temporal gyrus, specifically responding to pulse clarity. Changes in dynamics, rhythm, and the introduction of new instruments cause an uptick in the response. The study also identified the best song types of the perfect workout, sleep, and study. Your heart beats faster, pumps sweat, and part of your brain called the Heschel's gyrus light up like a Christmas tree. Chances are you never thought about what happens to your brain and body when you listen to music in such a detailed way. But it's a question that has puzzled scientists for decades. Why does something as abstract as music provoke such a consistent response? In a new study, a team of USC researchers, with the help of artificial intelligence, investigated how music affects listeners' brains and bodies and emotions. The research team looked at heart rate, galvanic skin response or sweat gland activity, brain activity, and subjective feelings of happiness and sadness in a group of volunteers as they listened to the three pieces of unfamiliar music. Of the 74 musical features examined, the researchers found dynamics, register, rhythm, and harmony were particularly helpful in predicting listeners' response. Taking a holistic view of music perception using all different kinds of musical predictors gives us an unprecedented insight into how our bodies and brains respond to music. Contrast is crucial. Amongst their findings, the researchers noted that music powerfully influenced parts of the brain in the auditory complex called the Heschel's gyrus and the superior temporal gyrus. Specifically, the brain responded to pulse clarity or the strength of the beats. They also found that changing dynamics, rhythm, and the timbre, or the introduction of new instruments, brings about the uptick in response. In other words, contrast is crucial. For example, the gyri activate when there is a change in dynamics or loudness. If a song is loud throughout, there is not a lot of dynamic variability and the experience will not be as powerful. It's a songwriter's job to take you on a roller coaster of emotions in under 3 minutes, and dynamic variability is one of the ways this is achieved. So, if you're listening to a whole album of black metal, which is constantly loud, you're probably not going to see a response. But if you're listening to music which goes from a quiet verse to loud and back again, it's a different story. The team also discovered that galvanic skin response, basically a measure of sweat, increased under the entrance of a new instrument or start of musical crescendo. And the saddest note of all, that award goes to the seventh note of the minor scale. The study found the note known as the sharp F in a song in G minor key positively correlated with high sadness ratings. For this experiment, the team selected three emotional pieces of music that did not contain lyrics and were not highly familiar, so no element of memory was attached to the listener's emotional response. In the neuroimaging experiment, 40 volunteers listened to a series of sad or happy musical experts while their brains were scanned using MRI. To measure physical reaction, 60 people listened to music on headphones, while their heart activity and skin conductance were being measured. The same group also rated the intensity of the emotion from 1 to 10 while listening to the music. Then, the computer scientists crunched the data using artificial intelligence algorithms to determine which auditory features people responded to constantly. In the past, neuroscientists trying to better understand the impact of music on the body, brain, and emotions have analyzed MRI brain scans over very short segments of time. For instance, looking at the brain reacting to 2 seconds of music. By contrast, in this study, using algorithms to analyze data gathered in the lab, the scientists were able to look at how people felt while listening to music over a longer period of time, not only from brain scans but also combining data from other modes. Novel multimodal computing approaches help not just eliminate human affective experiences to music at the brain and body level, but in connecting them to how actually individuals feel and articulate their experiences. In addition to helping researchers identify songs for the perfect workout, study, or sleep playlist, the research has therapeutic applications. Music has been shown to calm anxiety, ease pain, and help people with disabilities or dementia. From a therapy perspective, music is a really good tool to induce emotion and engage a better mood. Using this research, we can design musical stimuli for therapy in depression and other mood disorders. It also helps us understand how emotions are processed in the brain. According to the researchers, future studies could look at how different types of music can positively manipulate our emotional responses and whether the intent of the composer matches the listener's perspective of a piece of music. Thank you for watching the video. If you like the video, don't forget to like and follow my page so that you can get other updates in the future. Thank you.